today we're going to be doing part 2 of factoring polynomials, and we're going to be doing, there we go, we're going to be looking at factoring trinomials, which is where we left off yesterday. And this time we're going to be looking at factoring trinomials of the form ax squared plus bx plus c. And this is going to be where that lead coefficient does not equal 1. So the problems that we were looking at before, everything was all well and good for us because the lead coefficient was 1. Good to see you here, Tone, Toy. Hopefully things will be smooth today. We'll see. A few minutes ago, it wasn't. So we're here for the big stuff. You're here for factoring trinomials, the stuff that tends to throw us all off, mess us up because the lead coefficient is not 1. So, for example, yesterday when I took, or if I were to take x squared plus 7x plus 6, this should be a nice, easy one for us because the lead coefficient here is 1. And as long as that lead coefficient is 1, we just have to look at the constant term, find factors of 6, and one of those factors of 6 to add to 7. And again, this was the nice, easy stuff that we did yesterday, and we say 1 and 6 would be that combination that we want to use. And so we can factor this very easily with x and 1, and then x and 6. Paying attention to our signs, these guys would both be positive, like that. Okay? So, nice and easy, no problems there whatsoever. We can easily check this. 1 times 6 is going to give us the 6th there at the end. If we check inside and outside, there's the positive 1x. And on the outside, we have a positive 6x. So altogether, we had a positive 7x when we put everything together. Right? So everything's good. Hey, Kevin, thanks for showing up. Now, what if I were to take this polynomial, 2x squared plus 7x plus 6? See, now this is a completely different story because we can't just focus on the 6 and find factors of 6 that add to 7. We have to somehow incorporate this 2 in here. Now, there are a lot of different ways we have of factoring this, okay? I'm going to show you some of the common ways, maybe some of the not so common ways. And then we also want to talk about some of the thought processes that we have and the math logic that we can use so that we can make this a nice, easy problem for us. Now, one of the ways we have of factoring this is doing the same stuff that I did when I was a kid, which is to just guess and check. And when we do that, you're looking at the 2 and figuring out what are the different factor pairs you have for 2. So we have 1 and 2. So we know that when we break down 2x squared, we can only use 1 and 2. And that's it. You could say, what about 2 and 1? That's the same thing as 1 and 2. Over here for 6, we have 1 and 6, and we have 2 and 3. So with the different combinations that we have here, there are 4 different possibilities for factoring here. If we were to just check each of these, if we were to write out every single possibility, let's see what we have. So you could say x and 2x, because that has to be there because of the 1 and the 2. And if I do 1 and 6, we can see what happens there. Or, again, x and 2x, I could try doing 6 and 1. Let's see what happens if I were to swap the order of those factors. Or maybe it's the combination x and 2x, and I do 2 and 3. Or, and this is the only other possibility that we have, is rearranging the factors like that. Okay. Now, with the information we talked about yesterday, we can carry some of that over to today because we're still trying to find a combination so that we can add in the middle and end up with a 7. Okay? But we can't just look at these numbers or those numbers. We have to look at everything together. And I think that's what tends to throw a lot of students off. So if I were to just kind of work these guys out, here on the inside I get a 2x, and on the outside I get 6x. Well, this would lead us to something that has 8x when we add them, and that's not going to work out. If I look at this one, I get 12x on the inside, I get 1x when I go on the outside right here, and that would lead us to, when we add these guys, 13x. So it's still not good enough. Here, we get 4x on the inside, you get 3x on the outside when you multiply these, and when you add 4 and 3, that's the 7x that we're looking for, right? So really we could stop here and say, okay, we've got the right combination. But I do want you guys to remember that there is only going to be one factorization for this. Now the order of the factors may be different, but it's still going to be that same single factorization. So I don't want you to say, Mr. Greg, I found an answer that works that's totally different from what you have. Well, I'm sure there's going to be something slightly wrong with it, because it's going to have to give you 7x. So a lot of times it comes down to, did you pay attention to your signs? Now here, if I do this one, there's 6x, and on the outside, you're going to get 2x. So this leads us to 8x, which is not going to work. So back when I was much younger than I am now, this is what we would do. We would try to find any possible combination that would work. And we didn't really use a lot of logic. We just did it. It was brute force, which is a real shame that it took me so long to realize that it didn't have to be that way. So some of the techniques I'm going to show you are things that I, of course, learned over the course of teaching, or just from experience. And I realized, oh, I can make very quick work of these problems if I just, pay attention to a few things. Okay? So, we know that this is going to be the right combination for us. And we know that they're both going to be positives here. Okay? So I know this is kind of messy for what we're doing here. We're just kind of going through all the different possibilities to see what's going to work. And later on, we're going to talk about how we can avoid some of the wasted time. Okay? And that's what we want to focus on right now, starting right here. Okay, so let me go back and look at the different possibilities that we have. For 2x squared plus 7x plus 6. This right here is going to give us a problem from the very beginning, this 2x and 6. And the reason it gives us a problem is because there is a common factor here of 2. So when it comes to factoring, the first thing we're always going to look for is there a common factor to take out of everybody? So there is no common factor for all three of these terms, which means when you get down to these smaller factors, you can't have a common factor in any set of parentheses. So this has a common factor of 2, and if this guy actually did work out, that would mean that we forgot to take out a common factor from the very beginning. Here, these guys don't have a common factor other than 1. 2 and 1 don't have a common factor other than 1. So this was a viable possibility until we checked it to see that it gave us 13x, which was not the right number. This guy was already the answer, and down here, you've got 2x in the same set of parentheses as 2. So there would be a common factor of 2, but again, there wasn't a common factor of 2 at the beginning, so we can never have had that. So if you're coming down here and you're trying to figure out, okay, what can I do? If you are the kind of person that likes to guess and check, you know that 2x squared has to be 2x and x, because 2 is prime, and there's no other way to break that down. You have to do 2 and 1. When you look at the factor pairs for 6, you've got 1 and 6, and you've got 2 and 3. So we start thinking about what are the possibilities, right? If I try to do 1 and 6 like this, there's no common factor issues that we're going to run into, but we do run into the issue of that gives me 1 and that gives me 12, which does not add up to give me 7. The other possibility here is to swap and put the 6 here and the 1 here. But again, this is where we're running into that common factor issue, and we can't have that. So, and this is the process that you should go through, the thinking you should have when you're trying to do this by guessing and checking. But we're going to try to avoid some of the guessing and checking here in a little bit. If I do 2 and 3, the 2 can't go here because it would have a common factor with this, which forces the 2 to be over here in the other set of parentheses, and the 3 here. This is the only other possible combination that can even work. And we see, again, you get 3x, and you get 4x. And if I ask you the question, is it possible to take these guys and add them to get 7? Well, the answer is yes. 3 and 4 can add to give you 7, and it'll give you that positive 7 as long as everything here is positive as well. So here is your factorization again. Okay. Now, there is another way for factoring this. And we're going to be looking at all of these different ways all meshed together, because that's how I do it. It's not just one way and that's it, but I merge these different ideas so that when I see a problem that needs to factor, I've got a lot of different checks that I can do. That way I know that I'm going to be on the right path. So this other method is oftentimes referred to as the AC method. And the reason that it's called the AC method is because we're taking the A and the C. We're going to be taking this A and that C, and we're going to be multiplying them together. And when we multiply them together, then we're going to play the same number games that we played yesterday. But you've got to be careful about this. It's very easy to get thrown off and do some bad stuff, and you forget where you are. So the AC method would say to do this. So A times C is 2 times 6, which gives me 12. And with that 12, I'm now going to use the 12 here, and I want to find, let's do it like this. Let's find the factors of 12 that add to 7, not the 6. Find the factors of 12 that add to 7. And so when you think about your factor pairs for 12, the one factor pair that works will be 3 and 4. Now, it's great that we have the 3 and the 4, but we have to make sure that we apply them the right way. And this is where it kind of comes down to the same kind of topics that we would have had, same discussion we would have had with multiplying polynomials. When it comes to multiplying polynomials, there are a lot of different ways we have for multiplying them, but it's really all the same because it all comes down to how do you organize your material. So here's what we're going to do. I'm going to use the 3 and the 4 right here to rewrite the 7x that we have right there. So I'm going to rewrite this and say, this is 2x squared. I still have plus 6. I'm going to rewrite the 7 to be 3x and 4x. Now, in order for us to get a positive 7 here at the end, you have to have both of these guys to be positive. And so what we're doing is that we're changing the way the problem looks while keeping the meaning exactly the same. Okay? Because plus 3x plus 4x is the same as a positive 7x. But now that we have 4 terms, we can factor by grouping. So just like we were doing yesterday, we found that common factor for the first 2 terms, which is going to be x. We factor that out, and we are left with 2x plus 3. And then in the second group, we start with a positive, and the common factor for 4x and 6 is 2. When we factor that out, we again have 2x plus 3. And so this avoids some of the issues that we have with guessing and checking, because once you get to factoring by grouping, it just is that. And there's nothing else you really have to worry about. Then we finish this. The big common factor here is 2x plus 3. And the 2x plus 3 is connected to x and 2. So it's the same factorization that we had before. Whether you look at it up here or over here, it's exactly the same. Now, what we're doing here, when we split that middle term, should only be used when the lead coefficient is something that's not 1. So even though we could do factoring by grouping on a problem like this, if I take x squared plus 7x plus 10, you could do factoring by grouping on it, but it ends up being very, very unnecessary. Because when I'm asking you to find factors of 10 that add to 7, the 2 and the 5 that you find here are the exact same numbers that go in the factorization. They go in the individual factors. So you get x and 2, x and 5, and both of these guys are positive. There is no need to try to split up the 7x. Don't split up the middle term. Just take these numbers and you put them here. What I'm saying is that if you have a lead coefficient that's not 1, then you can take this guy and split it up based on the numbers that you get from doing the AC method. It's not just looking at 6. It's looking at the product of 2 and 6. Okay? So as long as we keep that in mind, we really shouldn't have any issues. So let's do another one. So let's take 8x squared plus 2x minus 3. Now, before you do any problem here, you're supposed to look for a greatest common factor. Is there something that these guys all have in common? And I mean something other than the number 1, because factoring out of 1 typically doesn't do much for us. And here, there is no common factor other than 1. So if we go up to the side and we try to investigate the AC method. Now, like I was telling you guys yesterday, I'm going to ignore signs for the most part. Look at the numbers. I'm just going to do 8 times 3. That's my A times C. Okay? Let me change something real quick. Now, with the 8 and the 3, the product here is going to give us 24. And then with that 24, we want to find factors of 24 that have a difference of 2. We're not looking at 3. We're looking at the product of A and C. So we're looking at the product of 24, finding factors that will subtract to 2. And so if you're not sure, think about all the different ways that 24 factors. You've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay? And so we want to find those numbers who have a difference of 2. And that's this guy right here, the 4 and the 6. So we can take this trinomial and we can rewrite the plus 2x using the 4 and the 6. Now it doesn't really matter what order you write. So if you want to say 6x then 4x or 4 then 6, it doesn't matter at all. So I am going to say 4x and 6x in that order minus 3. Now the real trick is going to be paying attention to your signs. So right now we need to pay attention to our signs. Remember one of the things I told you yesterday? I said that whatever the sign is of the middle term is also going to be the same sign of the larger of those two numbers. So in order for us to have a positive 2 at the end, the larger number has to be positive by default. We just need to figure out what this sign is going to be. In order for us to have a positive 2, they can't both be positive, because that would combine to a positive 10x. So this guy needs to be negative, which I think makes sense for us, because when you do 8 times 3, you only got this negative right here, so that negative has to go somewhere. And so now we're going to factor by grouping, because that's why we created the 4 terms. So in the first group, the common factor for 8x squared and 4x is 4x. Don't say that the common factor is 2. 2 is a common factor, but we want the greatest common factor. Okay? And then we take out the 4x and we are left with 2x minus 1. Don't forget about the minus 1 right here, because when we do 4 divided by 4, you still get 1. In the second group, the common factor between these two guys is going to be a 3. Don't forget the plus that's right here, so it's plus 3. We factor that out, and we are left with, let's see, 6 divided by 3 is 2, so we get 2x. And then negative 3 divided by 3 is minus 1. So these guys here are exactly the same. And we know that's going to happen. Okay? We were able to find a combination that was going to work to give us the 2x. And so if we can find that combination, then we can factor by grouping. There's not going to be anything that gets in our way to prohibit us from finishing factoring by grouping. All right, so that's 2x minus 1 times 4x plus 3. Before you go on, check everything. It doesn't take us too long to just visually inspect this. 2x times 4x is 8x squared. Negative 1 times positive 3 is negative 3, so that's good. And then you check inside and outside here. So on the inside, you get negative 4x. On the outside, 2x times positive 3 is positive 6x, and you get a positive 2x right there. So everything checks out, so we know that this answer is good. Okay? Now, that's one way of doing it. That's one way of organizing your material. Let me show you another way. Still using this AC method, so let's piggyback off of this. Many of you guys may remember using boxes to show multiplication when it comes to polynomials. We can do that here. And what we're going to do is we're going to populate the pieces inside the box. And we're going to try to backtrack to figure out what are the pieces on the outside edges of the box. So you've got your 8x squared, which is your lead term right here. Your minus 3 is over here. And then we're going to take these pieces that we used to break up that middle term, the minus 4x and the plus 6x. Again, it doesn't matter where they go. So I'm going to do minus 4x here and positive 6x right here. It's still the same number of terms, still the same exact terms, but it's just going to be a matter of where do we put these guys. Okay? So, if you look at this, it's all about finding the greatest common factor. So in this first row, our common factor for 8x squared and 6x is 2x. Now, that means we're taking a 2x out of both of these. So 2 goes into 8 4 times, so that should be a 4x. And 2 goes into 6 positive 3 times, so that when you multiply these, you get a positive 6x. Not only that, but if you look in this column right here, the common factor for 8x squared and negative 4x is 4x, and the common factor for 6x and minus 3 is a positive 3, which should make sense because that's what they were up here, right? On this row, for negative 4x and minus 3, 4 and 3 don't have anything in common except for the negative sign, so we can take out a negative 1 right here. And these guys that you see on the outside parts of the box method form your factorization. So it forms the factorization of 4x plus 3 times 2x minus 1. Still the same thing, just a different way of organizing it. Now, there is another bit of information that I want to show you. I think I need to wait though. Here's another way of factoring. Again, it uses both of these techniques. It's just a different way of organizing and setting up your work. Okay? So, one of the ways that I do my work is that I go ahead and I go straight to my 2 sets of parentheses. I'm still going to be doing the AC method in my head, so I know this. I know that I'm supposed to be getting the 4 and the 6 from before, right? That 4 and the 6 are going to be the pieces that show up on the inside and outside of the FOIL process. Now, I think to streamline things, put the large number for the inside part and put the smaller number for the outside part. And what we're going to do is we're going to kind of backtrack everything. Okay, and it's just, it's a different way of doing the factoring by grouping without actually showing, factoring by grouping. The 8x squared has to split up to be at the beginning of each of those binomial factors. That means that part of 8 is going to go into 4, and another part of 8 is going to go into the 6 that you have here in the middle. Because he's splitting up and he is contributing different parts of himself to the two pieces that we have in the middle. So we're going to focus on this piece on the outside right here, the 4x. If you look at just these two guys right here, once you find the common factor for these two terms, that's what goes right here. So the common factor for 8 and 4 is going to be 4 along with their shared factor of x. Once you have that one number, that forces the hand for everybody else. It's like when you're playing tic-tac-toe, and you eventually get to that point where you have to make a certain move so that you don't lose the game, which then means your opponent has to make a certain move to block you so that you don't win the game. And it goes back and forth like that. And that's what's happening here. So what I'm saying is that 8 is going to break down as 4 times something else. So think about it. 8 breaks down as 4 times 2. So the 8x squared is breaking down as 4x times 2x. And again, I got the 4 because that was the common factor for the 8 and the 4. The rest of this is just a bit of division. 4 goes into 4 one time. 2 divides into 6 3 times. So look at what we have. 4 times 2 is 8, which is that guy. 3 times 1 is 3, which is that guy. You get your 6x and your 4x from the inside and outside, but now we have to make sure that we use appropriate signs to get a positive 2x. To get the positive 2x, the larger number has to be positive, like we've talked about. And in order to be a positive 2, that means this positive 6 is being cut down by a negative 4. And then you just push those signs back up. Where does the positive 6 come from? He gets his positive from the positive 3. The minus 4x is coming from the outside pieces, which means he gets his negative from that guy. Still the same process. In fact, I like this guy so much, I want us to go back and look at that first problem that we had. 2x squared plus 7x plus 6. Now, keep in mind that we've already done the work on that, and we know that the numbers are going to be 3 and 4. So here is what this work is going to look like for this problem. On the inside and outside is where I put my 3 and the 4. So I'm going to put 4x up here and 3x down here. Again, the order is not going to matter. Doesn't matter at all. This first piece right here is going to be finding what's the common factor for 2 and 3. Since 3 is coming from the outside pieces, that's where it's going to be matching up. So the common factor for 2 and 3 is just 1. So that's just 1, and they also share x. And once I've got the 1x in place, that tells you everything else. So we're saying that 2 breaks down as 1 times the other factor is 2x. And you know that you're on the right track because you're going to have numbers that divide evenly. For example, 1 divides into 3 times. 2 goes into 4 2 times. They go in evenly. Nothing weird going on there. And look at this. 2 times 3 is your 6. 1x times 2x is 2x squared. You pay attention to your signs. We're supposed to end up with a positive 7x at the end. Both of these are positive, which means both of those numbers are positive. So again, it's really the same thing. It's just a different way of organizing those middle pieces there. Okay? Now, doing the AC method is okay, but it's not always the most efficient way of doing a problem. Okay? But if you've got a calculator, we talked about how we can make very quick work of some of these problems. We talked about that yesterday. Let's see if we can stay away from the calculators for just another problem. So let's take 10x squared minus 13x plus 4. All right, so the first thing I want to do is to see, is there a common factor for all three terms? And I think it's pretty clear that there is not a common factor for all three terms. Right, 13 is prime, and so he just kind of ruins it for everybody else. So then off to the side, we can do the AC method. The AC method would say to do the lead coefficient times your constant term, which is 4, and that product gives us 40. And then from here, we want to find factors of 40 that will add to 13. Now remember, I'm not looking at the 4 right now, I'm looking at the product of A and C because that lead coefficient was something other than 1. If you don't know, then you list all of your factors for 40. So we've got 1 and 40, 2 goes into 40 20 times, 3 doesn't go into 40, 4 goes in 10 times, and if you look at this, we want these numbers to add to 13. That's 41, that adds to 22, this adds to 14, so we're getting closer. One more step, one more factor pair, 5 times 8, this is the combination that we're looking for, because 5 times 8 will add to 13. Okay, so you've got a couple of different ways of doing this. You can do the box method like we were doing before. You may split up that middle term so that you can do factoring by grouping, or we can do the method that I was just showing you. So let me do my method first, and then we're going to go back and split up the middle term so that you can see that it's all the same. It's all the same. So remember, my method goes ahead and it's going to take the 5 and the 8, and it's going to use those to basically put the pieces in here for checking. So I'm going to do 8x here and 5x here. And as I mentioned before, the order of these two terms doesn't matter. But our focus, remember our focus, we're trying to break down 10x squared to be at the beginning of each of these parentheses. And we know that the x is going to be x times x. What numbers do I use? Do I use 1 and 10? Do I use 2 and 5? And where do they go? What I'm showing you here is like factoring by grouping. It's not a guessing game. You just do it. So the common factor for 10 and 5, because 5 is on the outside, the common factor for 10 and 5 is 5. And we're going to go ahead and put the x there because we know that's what's supposed to be there, because the common factor for x squared and x is x. So 10 breaks down as 5 times the remaining factor is 2. Check this real quickly. 5x times 2x is 10x squared. Not only that, but look at the division that we're going to be doing. Does 5 go into 5 evenly? Yes. Does 2 go into 8 evenly? Yes. So let's finish that. 5 goes into 5 one time, 2 goes into 8 4 times. We've got the numbers in place. We now have to determine our signs. So with the 8x and the 5x, look at the middle term. We were supposed to end up with a negative 13x. Don't let the signs get you down. Remember, whatever your sign is for the middle term, that is also going to be the sign for the larger of the two numbers that are inside, for the inside and outside pieces, of the FOIL method. But in order to get a negative 13, that guy's going to have to be negative. We kind of knew it was going to be going there anyway, because look at this constant term. This is a positive. In order for you to get a positive, you have to be multiplying two positives or two negatives. Well, how do I know if it's two positives or two negatives? You look right here. You have to get negatives somewhere, and you're not going to get negatives with just positives. So we backtrack this. It's 5x minus 4 and 2x minus 1. Before you go on, check everything. 2x times 5x gives you the 10x squared. Negative 4 times negative 1 is positive 4. And we already have here in the middle, negative 4 times 2x is negative 8x. 5x times negative 1 on the outside is negative 5x. And these guys do combine to give us negative 13x. Okay? So it's not a guessing game. What we're trying to show you here is that, yes, you can go and solve, not solve, but you can factor these guys by guessing and checking. But by using good, solid logic, you don't have to. Now, you may have to go through the different factor pairs until you find one that works. But that's not really guessing. That's using logic. That's going step by step. That's making sure that you haven't missed anything. Now, if you wanted to break up that middle term, and you pay attention to your signs, so you'd have a minus 8x and a minus 5x plus 4. Now, what we're showing you here is only going to work as long as you know how to combine 5 and 8 to get 13, and you don't think that 4 and 10 is 13. Because once you think 4 and 10 has to be 13, that's a different issue that needs to be addressed. So here, the common factor in this first group is 2x. When you factor that out, 5x minus 4. Now, if you're still struggling with finding the common factor and factoring by grouping in general, I suggest that you go back and watch part 1 of factoring so that you can get caught up on everything. The second group begins with a negative, so we factor out that negative. And, well, 5 and 4 have nothing in common except for 1. So we divide or factor out that negative 1, we get positive 5x and minus 4. And look, we can now finish our factoring by grouping. So 5x minus 4 times 2x minus 1. Okay? Two different ways of working the same problem, yet the end result is exactly the same. All right? That's it. So let me give you this one to try. All right. So let's factor 9x squared minus 22x plus 8. All right. So talk to me about what your thought process is going to be. What's the first thing that we're going to be looking for? Because we cannot forget to look for a common factor. Always look for a common factor first. It doesn't matter what kind of factoring problem you have. Always look for a common factor first and factor that out. So there is no common factor here. So if we want to do the AC method, we're going to multiply 9 times 8. So off to the side, A times C is 9 times 8, and that product is 72. And with that 72, we want to find factors of 72 that add to 22. Now, if 72 is one of those numbers that you're not that comfortable with, you're going to make a list, and you're going to list all of your factors. Even if you get to the combination that ends up working out for you, the combination of numbers that will add to 22, I still want you to be in the habit of listing all of the factor pairs, because when you do that, when you see 72 again, you're going to know those factor pairs even better. That way you don't have to keep doing like math over and over, you just know what it is. You know those multiples, those factors in your head. So as we were showing yesterday, on our graphing calculator, we can find all of those factor pairs very easily. So I think yesterday we had 144. So today we have 72 divided by x. So if I put that under y1, and I go to my table, okay, I gotta scroll back up here. So starting at 1, I've got 1 and 72. And then the next combination, so 2 gives me 36. 3 goes in 24 times. Go down to 4, I get 18. 5 doesn't work. Of course, we knew it wouldn't work because 72 doesn't end in a 5 or a 0. 6 goes in 12 times. And then we get to 7 that doesn't work. 8 goes in 9 times. Then we go down to 9, we're back at 8. And so we're just going to be going back up now. Okay, so these are the only possible factor pairs that we have. If there is not a factor pair that's going to add to 22, then we've either done something wrong or the problem can't be factored, in which case we would say it's prime. So let's see. We want these guys to add. So these guys add to give me 73. These add to give me 38. Then 27, so we're getting closer. And then we land here at 4 and 18. Those guys add to give us 22. And we don't even need to look at the rest of these guys. Okay? So using the 4 and the 18, I want to use the method I was using earlier, because I know the 4 and the 18 are part of the inside and outside of this FOIL process that we would be checking. And again, I say put the large number for the inside piece and the smaller number for the outside piece like this. So 18x, excuse me, 4x. We said that 9 is going to split up to be at the beginning of each of these. So the common factor for 9 and 4, well, they don't really have anything in common except for 1. So we're just going to write x. So that means that 9x squared is going to split up to be x, and the other factor for 9x squared is 9x. Now again, we want to check to make sure that we're on the right track. Does 1 go into 4 evenly? Yes. Does 9 go into 18 evenly? Yes. So 1 goes into 4x, or 1 goes into 4 times, 9 goes into 18 2 times. And you see very quickly that 2 times 4 is the 8 that we're looking for. All right. So I need to combine these guys to get a negative 22x. So paying attention to our signs, we said that the large number is always going to match the sign of the middle term. So it's going to be a negative 18x. And to end up as a positive here at the end, the signs have to be the same. So negative 4x. So this becomes x minus 2 and 9x minus 4. Negative 2 times negative 4 gives you the positive 8. These guys give you the 9x squared. And we just showed you that the pieces on the inside and outside parts of the FOIL process combine to give you a negative 22x. Pretty good, right? Now, there's some other logic that I want to show you. And this is logic that in the college algebra class I wish we had time to show, but we just really don't have the time to do that. So for you watching the video, you're getting some bonus information. Okay? Alright, here we go. This trick requires you to be able to write the factor pairs for both the leading coefficient and the constant. So 9 can be broken down as 1 times 9, or 3 times 3. 8 can be broken down as 1 times 8, or 2 times 4. Now, just off to the side, I want to kind of give you a heads up for how what we're showing here, how it works, and what the logic really means. So I just want you to consider the following. If I have something like this that is, say, 7x and something times 7x and something. When I do the inside right here, whatever it is going to be a multiple of 7. On the outside, 7 times really any other integer is going to give you a multiple of 7, which means when you combine these guys, that middle term would also be a multiple of 7. Okay? So the reason I'm showing this to you is because of some of these factors that we have up here. if you try to break 9 down as 3 times 3, because of the way that it works, if I broke this down and I said 3x times 3x, the inside piece would be a multiple of 3, the outside piece would be a multiple of 3. So that means that when you combine the inside and outside, you would have a result that is a multiple of 3. But look at 22. 22 is not a multiple of 3, so you can't use 3 and 3. It just doesn't work. It will lead you to just to a contradiction. So we can't do that. And knowing that we can't do that, and not even worrying about what AC is, not even worrying about what the middle two pieces are going to break up to be, like we had up here with the 18 and the 4, I know that 3 and 3 cannot be used. The trick that we're doing here works not only for the lead coefficient, but also for the constant term. So if you see any factor pairs that have a common factor, highlight them, and then see what we can get from it. So the 3 and the 3, we highlight that. These guys have a common factor of 3, which means they are both multiples of 3, but since 22 is not a multiple of 3, he's gone. Over here for the factor pairs for 8, 2 and 4 are both multiples of the number 2. In other words, they have 2 as a common factor. So if I were to use 2 and 4, that would force the middle term to be a multiple of 2. And look at 22. 22 is a multiple of 2, so that means we should be using that. Because if we use this, it's going to force the middle guy to have a multiple of 2, or to be a multiple of 2, which he is. So that means I can go ahead and say this is going to be a 2, and that's going to be 4. And now it just comes down to where do I put the 1 and where do I put the 9. So if you were playing around with these numbers and you just didn't know, and you said, oh, okay, I'm going to do 9 here and 1 here. 9 times 4 is 36. 2 times 1 is 2. 36 and 2 are not going to, remember, you're trying to add to get 22. 36 and 2 don't add to 22. Now, we already know that's not going to be the right answer because we already know the correct answer. So by swapping these around and putting the 9 here and the 1x right here, now you've got the right middle pieces that we're looking for. 18x and 4x, if we do the appropriate signs, they're both going to be negative, and that combines to give us a negative 22x. Just like that. In fact, let me go back up to the problem that we had at the top of this page, just so you can see how the logic works out. Alright, so let me take this 10x squared minus 13x plus 4. The factor pairs for 10 are 1 and 10, 2 and 5. The factor pairs for 4 are 1 and 4, and 2 and 2. And if you look at all these factor pairs, you're trying to find any and all factor pairs that would contain a common factor. In other words, they are multiples of the same number. 1 and 10 don't have a common factor other than 1, so they don't really help me out. 2 and 5 don't have a common factor, nor do 1 and 4. However, 2 and 2 do. These guys are both multiples of 2. Now, in order for this to be a combination that works for us, 13 would have to be a multiple of 2. But since 13 is not a multiple of 2, I can't use the 2 and the 2. And instantly, that forces my hand, and it forces me to use 1 and 4. And so now it comes down to the factor pairs for the 10. Which ones do I use, if any? So this goes back to the logic that we did on page 1. If I try to do 1 and 10, I can't put the 10 here, because if I do, 10 and 4 have a common factor, but there was no common factor up here. So it's not even worth my time if I'm guessing and checking. Let's guess and check logically. If I put the 10 here and the 1 here, I get 40 on the outside, 1 on the inside. 40 and 1 do not add to 13. So that's a bad combination. That leaves us with only one other possible combination, the 2 and the 5. Now notice that 2 and the 4 have a common factor, so the 2 cannot go here. The only combination that can work logically is to have the 2 over here and the 5 in the same set of parentheses with the 4. Putting in the appropriate signs, you see that this does work out, and it's the same answer that we had right here. So using logic, we can eliminate a bunch of possible combinations. So at the beginning here, there were a total of 12 possible combinations by putting these numbers in different orders and different sets of parentheses. By crossing out the 2 and the 2, we went from 12 possible combinations to 8. Wait, no. I'm sorry, my numbers are all messed up. Excuse me. At the very beginning, there were 6 possible combinations with the numbers. So I got an extra factor of 2 in there. By crossing out the 2 and the 2, you get rid of 2 possible combinations. By avoiding common factors inside here, you get rid of 2 other combinations. So you go from 6 possible factorizations to 4, then to 2, and then with these 2, 1 works and 1 gave us numbers that weren't even close. So logic can get us pretty far if we just pay attention to it. Alright, so let's try this problem, and let's try to apply some of the logic that we just talked about. 25x squared plus 25x plus 4. Now, again, you could just jump right into this and start doing the AC method. But first, is there a common factor for everything? So 25, 25, and 4, they don't have anything in common, so that's not going to work. Let's look at those factor pairs and see if we can come up with some kind of logic that's going to help us out. So 25 could factor as 1 times 25 or 5 times 5. 4 can be 1 and 4, or it can be 2 and 2. So, we're trying to find factor pairs that have a common factor. 5 and 5 right here have a common factor of 5, which means if I were to break down 25 using 5 and 5, I'd get a multiple of 5 for the middle coefficient, which I do. So since this guy goes into 25 evenly, in other words, 25 is a multiple of this common factor, then I should probably use that guy whenever I factor. Over here, I've got 2 and 2. 2 and 2 are both multiples of 2, but since 25 is not a multiple of 2, I can't use that combination. So remember, if I use 2 and 2, that would force the middle coefficient to be a multiple of 2. So logically, I can't use that. If I use 5 and 5, that's going to force the middle coefficient to be a multiple of 5. It is, so I should use that. So when it comes to factoring, I'm going to go ahead and split up the 25x squared as 5x times 5x. And I just have to put the 1 and the 4 here. And since these numbers are both the same, it doesn't matter where I put the 1 or the 4. Either way, it's going to give me the same thing. So on the inside here, I get 5x. And on the outside, there's 20x. And if I do the appropriate signs here, I can get 25x as long as these guys are all positive, which I can make happen, right? Everything here is positive, so I'll do a positive 1 and a positive 4. Then everything works out just the way it's supposed to. So we can use logic to save ourselves a bunch of time. Or For those of you who really want to do the AC method, check this out. A times C is 25 times 4, which gives me 100. So I want to find factors of 100, that add to 25. So as you go through here, 1 on 100, 2 and 50, 4 and 25, 5 and 20, and then finally 10 and 10. Which, excuse me. Which of these guys add to 25? It's 20 and 5. The same numbers that we see right here. Okay? So there you go. Now, of course, these guys can always get bigger and better and nastier and stuff, but I hope you guys understand like the general idea about what's going on here. I could take the 5 and the 20, and I could rewrite this as 5x plus 20x and factor by grouping. It's all going to be the same. It's all the same. So let's just do one more to kind of wrap up this little portion right here. And let's try 4x squared minus 17x minus 15. All right. First of all, is there a common factor for all three of these terms? And the answer is no. You've got 4, but that guy's prime, and so you're already kind of out of luck there. You could do the AC method. You could also look at the different factor pairs that make up 4 and 15. But you know, just to kind of wrap up this one little section, let's do the AC method one more time. If I do A times C, that's 4 times 15, which gives us 60. And again, I'm ignoring the signs until the very end. I want factors of 60 that can subtract to give us 17. So if you look at the factor pairs here, you got to be very careful because it's all about the signs. Okay. So we got 1 and 60. 2 and 30 don't subtract to 17. 3 and 20, they subtract to 17, right? Yeah. But here's where you got to be careful. If you keep on going, if you get just a little careless here, you get 5 and 12, you get 6 and 10. Some students will point to the 5 and the 12 and they'll say, 5 and 12 will get you 17. Right, but this is where you look at this sign right here. You want your two numbers to be able to subtract to give you 17. And that's why 3 and 20 is going to be the winning combination here. So let's use the 3 and the 20 to split up the middle terms. So 3x and 20x minus 15. But we need to go ahead and address the issue of signs. Since the middle coefficient is negative, the larger of these two guys, the 20, has to have that same sign. And in order to end up with a negative at the end, you have to have a positive and a negative, which is going to force this guy to be positive. And then from here, you factor by grouping. In the first group, the common factor between 4x squared and 3x is x. Factor that out, and we've got 4x plus 3. In the second group, now sometimes you can get some help to figure out what you're supposed to get from this. So you're supposed to be left with a 4 on the inside here. So how many times does 4 go into 20? The answer is 5. So that means I should be factoring a 5 out of the second group. Now, that should also be a negative, right? Now, before I go on, just check to make sure this is going to work out. Does 5 go into both of these guys? And the answer is yes. So negative 20 divided by negative 5 is positive 4. Negative 15 divided by negative 5 is positive 3. Okay, so there's your common factor. We can factor that out in front. So 4x plus 3 times x minus 5. Check everything, right? So that is going to give you the 4x squared when you multiply. Positive 3 times negative 5 is negative 15. On the inside, positive 3x. On the outside is negative 20x. And when their powers combine, we get negative 17x. Okay, so everything checks out. Now you could have factored this using any of the methods that we've talked about today. Just make sure that you pay attention to your signs and everything's going to be okay. Alright, so we're almost done with our factoring review. There's still a couple more things we need to mention. Some stuff that is pretty quick. You just have to know the formulas. So there are some factoring formulas that we need to know. And these factoring formulas pertain to factoring binomials. So if we have the difference of squares, the difference of squares is a squared minus b squared, anything that's of this form. This is going to factor as a plus b times a minus b. Please note the following, that if you have the sum of squares does not factor over real numbers. The sum of squares does not factor over real numbers. So if you see it, just walk away. It's not going to be there for you. So what that means is that I can take something like this. I can take the x squared minus 25, recognizing that I do have squares here because this is x squared minus 5 squared. So by recognizing that both of these guys are squares, they come from, these two numbers come from these guys being squared, then I can factor this by saying x plus 5 times x minus 5. So once you've identified what your a and b are, so like that's your a and that's your b, then the factorization becomes a plus b times a minus b. And that's all we have to do. Don't try to do anything extra. That's it. So as long as you know your squares, you're going to be fine. If I do x squared minus 144, so x squared clearly is a square. 144 is also a square. It's the square of 12. So my factorization will be x plus 12 times x minus 12. And that's it. A lot of students want to try to do more, but no. Let's try x squared minus 9y squared. So if I didn't have the y squared there, it should be a fairly simple problem. We can at least identify that this is a square, 9 is a square, but look, y squared is also a square. So if you have a hard time when these expressions get a little more complicated, you can take time to rewrite this to say this is x squared minus, what would you square to get each of these pieces? Like what do we square to get 9? We would have squared 3. And what do we square to get y squared? Y. And so it's these guys right here, the a and the b, that we use to complete our factorization. So x plus 3y and then x minus 3y. Like and we're done. I feel bad. I feel like these should be more complicated. I feel like I should add extra steps or something just to have a little bit more fun. Hopefully everything here is going okay for you, so that I won't feel bad about giving you this. 49x squared minus 64 y squared. Excuse me, y squared. Okay, so this is getting a little bit more complicated. First, is there a common factor to take out of these guys? They have different variables, so there's no common factor with that. 49 and 64 have nothing in common. But they can both be written as a square. So what would you have squared to get 49? 7, and you would have squared the x to get x squared. Thank you. There you go, Kevin. Kevin is on top of things. You would have squared 8 to get 64, and you would have squared y to get the y squared. And so once you have these pieces identified, that's 7x plus 8y, and then 7x minus 8y. So again, as long as you know your squares, we're going to be in very, very good shape. Even if I go off my rocker, and why did I write an equal sign? What am I doing here? I've got this. Or do I not have this? All right. So when you have, this guy, you can pretend it never even happened. What is it, girl? What, Timmy fell in the well? My dog's trying to communicate with me. Or she's just trying to scratch my arm. She's just trying to make Superman bleed. It's okay, girl. So let's do fractions. X squared minus 169 over 100. If I just gave you x squared minus 169, that should be fine as long as you know that 169 is 13 squared. Well, 100 is also a square, right? So we can split this up and say that 169 is 13 squared, 100 is 10 squared. So then the factorization is just x plus 13 over 10 and x minus 13 over 10. See, we do not need to be concerned whatsoever about having fractions here. Now, you do need to be mindful of some things, though, because sometimes the difference of squares can be hiding. So if we have x to the fourth minus 81, 81 is clearly a square. X to the fourth is also a square because it's the square of x squared. So we can factor this as x squared plus 9 times x squared minus 9. And again, that's stemming from the fact that we have x squared squared here, and then 9 squared there. Now, a lot of students will get to this point and they'll think, sweet, I'm done, I can box this and go away. But look at this guy right here. You had x squared minus 9. See, x squared plus 9 is done because you can't factor the sum of squares using real numbers. But x squared minus 9, oh, we can do something with that. So this stays as x squared plus 9, but then x squared minus 9 becomes x plus 3 times x minus 3. This is the complete factorization for x to the fourth minus 81. Hopefully that's not too bad. Hopefully you'll take the time to start looking for hidden differences of squares, because these guys can show up whenever we're factoring by grouping. They can show up just in just regular factoring, even factoring in certain special trinomials that we looked at yesterday. So we always want to be aware of those guys. Now, if this had been, say, a 5, right, x squared minus 5, although x squared is a square, 5 is not, so you wouldn't be able to factor that anymore. But this is a square, and that's a square, so that's why we get to go a little bit further here. All right, let's get to the last topic for today, something that a lot of students tend to struggle with because of the formulas. So we're talking about factoring the sum or difference of two cubes. So the sum of squares cannot be factored. However, the sum of cubes can be factored. The factorizations for both of these types of binomials are very, very similar to each other. In fact, the only thing that's different would be the signs. So what I'm going to do first is I'm going to show you the pattern, and then I'm going to come back and address the issue of signs. So the pattern is going to be a, b, a squared, ab, b squared. Now that's for the sum of cubes. And for the difference of cubes, it's also going to be a, b, a squared, ab, b squared. Exactly the same. But now it comes down to the signs. So there's a trick for the signs. And we use this little acronym, SOAP. Okay. So for SOAP, S stands for having the same sign as what you have right here. So if you have a sum of cubes, you keep the same sign as that for the first part. O stands for the opposite sign. So if you have a positive, the opposite of that is a minus. AP means always positive. So that last term is always going to be positive, no matter what. So down here, if I follow along with SOAP, the same sign as a minus, minus. The opposite of the minus is plus, and the last guy is always positive. So notice the pattern. They both go A, B, A squared, AB, B squared. But then their signs follow the pattern for SOAP. And this is one of those places where you need to know what your cubes are so that you can factor correctly and identify that you have cubes to begin with. So if I ask you to factor x to the third plus 8, we need to be able to identify that what we have is the sum of two cubes, because we can rewrite this very easily as something to the third plus something else to the third. And those two somethings are x and 2. So please notice that I'm not going to be using 8 when I'm doing my factorization. I'm using what I cubed to get to 8, which is the 2. So the x and the 2 are the pieces that I'm going to be using. This is my a, and this is my b when I go to my formula. My formula is made up of two factors. One is a binomial, the other is a trinomial. So remember the pattern. It was a, b, a squared, ab, b squared. Our signs, SOAP, same as that. The opposite of that, always positive. There's our formula. We already identified what A and B are, so it's just a matter of plugging into the formula, and we're going to be done very, very quickly. So A, that's x plus plus. B, 2. A squared, so if A is x, if I square that, I get x squared, minus the product of A and B, the product of x and 2, is 2x, plus, because the last guy is always positive, when you square the b, please don't write 2 squared. 2 squared is 4. And there you have it. Now, a lot of times we get fooled into thinking that I can do more with this because we see the x squared and we've just spent all this time factoring trinomials. But if we are factoring using the sum or the difference of cubes, once you use that, you're done. There's not going to be anything else that you can do. All you can do is box it. Okay? Let's try this one. Let's see. Let's do x to the third minus 125 y to the third. Again, if you know your squares and your cubes, it makes factoring so much easier when it comes to these binomials. First, is there a common factor between these two terms? The answer is no. But can I write this? Can I write this as something cubed minus something else cubed? Can we identify what those two somethings are? Well, yeah. Clearly, this is going to be x. I mean, x to the third is x to the third. What would I cube to get 125? It's going to be 5. And to get the y to the third, I need my y there as well. So, just as we did in the last example, box this so you know that's what you're using for A. Box this 5y because that is the b that you're going to use. And so now, we factor a binomial factor times the trinomial. Remember what we said about the pattern for our factorization? We said it's going to go a, b, then a squared, ab, b squared. And now it comes to the issue of addressing your signs, right? So, you have the same sign here, so that's going to be a minus. The opposite sign is a plus, and then the last sign is always positive. So we memorize the formula so that we can use the formula well. We've identified our a and b, and now it's just a matter of plugging it into the formula. So a is x, there's my minus, and b is 5y. Don't forget about the y. A squared. So if I square x, I get x squared. Plus is plus. The product of a and b. So the product of x and 5y, the coefficient is 5, and you put the variables next to each other as x, y. Plus. All right. You've got to square 5y. Please understand that you're not going to square 5 alone. You're not going to square y alone. You're squaring that entire group. So that means you've got to square the 5 to get 25. You square the y to get y squared. Don't say 25y. Don't say 5y squared. You're squaring both factors, both the 5 and the y. And we're done. Okay? And let's wrap it up. Let's wrap it up with this problem. So 64 x to the 6th plus 27 y to the 15th. Again, we always want to make sure that we are mindful of looking for the greatest common factor before we just dive in and do stuff. But there is no common factor here. Since I have two terms, I'm going to be looking for the difference of squares. But I don't have a difference. I've got the sum. So I can't do the sum of squares. I can't even look for that. I'm going to be looking for the sum of cubes. Can I write this as something to the third? And can I write the other guy as something to the third? Can I figure out what those guys are? Now, if you know your cubes, it's got to scream to you, because 64 is 4 to the third. And when it comes to the powers here, remember that when we do a power to a power, we multiply. So if I'm trying to put something back into a power, it's like you're going to divide that. So 6 divided by 3 is going to give you 2. And you can see here that if I cube the 4, I get 64. Power to power, I multiply those, and I get x to the 6th. What would I cube to get 27? That's 3. And here's going to be y to the 5th power. This guy right here is the a that I'm going to use in my formula, and this is the b that I'm going to use in my formula. So I'm going to need a little bit of extra room, so I'm going to do it underneath here. Know the pattern. We said that was a, b, a squared, ab, b squared. Your signs. The same sign as that is plus, the opposite is a minus, and the last guy is always positive. And since we know our a and b, a, we just bring that down as 4x squared plus the b, 3 y to the 5th, a squared. Now this is where it gets tricky, just like the last problem. You're trying to square 4 and x squared. So square the 4 to get 16, square x squared, and you get x to the 4th, minus. All right, I've got to multiply these two guys together. So I'm going to do the easy part first. 4 times 3 is 12. And then we just tack on those variable pieces as you see them. X squared and y to the 5th. Finally, b squared. 3 squared is 9. And when you square the variable part, y to the 5th squared is y to the 10th. I know it's big, it's messy, it's kind of gross. But step by step, piece by piece, you can get it. It doesn't have to be all that bad. All right. Well, I think this is a good place to stop. Remember that you can always find me here on YouTube, Twitch, Twitter at mathman1024. Tomorrow, the plan is to review radical expressions. So we're just going to do a quick rundown of working with square roots, cube roots, and other higher order roots and radicals, how to combine like radicals, what does that look like, what does that mean. In addition, I had it and I lost it. Yeah. Well, yeah, so it's going to be all about radicals. Oh, that's what I was going to say. Rational exponents. So not just these nice guys like x squared and x to the 5th, but what if it's x to the 3 halves? Or something to the 3 halves power, or the 2 fifths power. What does that mean? So that's what we're going to be looking at tomorrow. Same time, same channel, here at 3 p.m. Central. Remember, stay safe out there, take care of others, and I'll see you later. Have a good one.